Chapter 6.1 Properties of Square Roots. Key ideas: simplifying radicals. Simplifying radicals involves the process of prime factorization. Recall, factors are two numbers that multiply to equal the given product. So for example, if you have 12 and the factors of 12 are 2 times 2 times 3, they are prime factors. But if you have just simply two factors of 12, that's going to be 4 times 3. So the two numbers that multiply to get the original number. Prime numbers are numbers whose factors are only 1 and itself. So for example, if you're going to do the factors of 150, you can find the factors of 150 by making a tree branches. So the easiest two factors that you're going to get from 150 is 15 times 10. And now you're going to break the 15 down furthermore as 3 times 5 and 10 as 5 times 2. Remember that 150, it is in a radicand or a radical symbol. So the factors that you got is 2 times 3 times 5 times 5 in a radical symbol. So now you're going to circle the pairs of factors that are same. So circle them if they are same. So in this case, if you have this 5 times 5, that is a one pair and you do not see any other pair. Once you get the pair, you take out one number from each pair. So if you have a one pair of 5, take out 1 5 out and remaining number will stay inside. So that's going to be 5 times 2 times 3. So this is the pair that you get. Take out each number from each pair. So we have only one pair, so we're going to take only one number, and that is 5. So when you solve this square root of 150 and break it down, you got the answer as 5 square root 6. Example number 1, simplifying radicals. To simplify radical, we are going to find the prime factors of 80. So you can do that 8 times 10. And 8, you can further divide it into 4 times 2 and 5 times 2. Now 4 can be further divided into 2 times 2. And the end numbers are 2, 2, 2, 5, and 2. So now you're going to rewrite this in a radical form. So you're going to get 2. So there are 1, 2, 3, 4 2s. So 4 2s. And then you're going to have a 5. Now we're going to see if they make pair. So I can see that here we have one pair and we have another pair. And we are going to take out one number from each pair. So one number from each pair means that we're going to take out 2. And we're going to take out another 2. Left inside is your number 5. So answer is 4 square root 5. For example, letter B, you're going to factor 21 into prime factors. And the only two factors we got for 21 is 7 times 3. So we did not get any pair, so that's why the 7 times 3, that is 21, will stay inside as it is. You tried problem number 1. You're going to make prime factors for 12 that are going to be 4 times 3. You can break down 4 further to two numbers, 2 times 2, and then you're going to have 3 numbers, 2 times 2 times 3. Those are the prime factors for 12. Now 2 times 2 makes a pair, so you're going to write down them into a pair. Take out one number from each pair, so that's going to be 2 square root 3. Next is number 2. You're going to break 72 down, and I'm going to use a factor tree. 72, it can be broken down into 12 times 6. So 12 has two factors, 4 and 3, and 4 you can further break down into 2 and 2. So the end numbers are 2 times 2 times 3 times 3. 2 times 2 makes one pair, 3 times 3 make another pair. Taking out each number, one number from each pair. So one number from this pair, which is a red circle, that's 2. One number from this pair, that is 3, outside. Inside you're left with 2. Multiply the numbers that are outside of the radical symbol. So 2 times 3 is 6, square root 2, and that's going to be your answer. Next, we're going to break down 30. So 30 is 15 times 2, and 15 you can break down further into 5 times 3. You can rewrite them into a radical symbol, 5 times 3 times 2. None of them make a pair, so you cannot take any number outside of the radical symbol. So the answer should be square root 30. Next, we are going to break 200. You can break 200 into 2 times 100, and you can just do this differently by writing 2 times 100. And you know that square root of 100 is 10 outside, and the answer is this. But since we are using factor tree, so I'm going to use a factor tree to solve. So 200 can be broken into 2 times 100. 100 is 10 times 10. And then 10 can be further broken into 5 times 5 and 5 times 5. All the end numbers write into the radical symbol. So there are 1, 2, 3 2's, and there are 2 5's. So one pair you got is 2 times 2, another pair is 5 times 5. Taking one number from each pair outside, so you have 2 times 2, take one number outside. 5 times 5, take one number outside. 2 times 5, you got 10, and inside you have a square root 2. So your answer is 10 times square root 2. Key ideas: product and quotient property of radicals. Product property of radicals. The square root of a product may be written as the product of square roots of its factor. So for example, if you have square root of x times y, you can separate them as a square root of x times square root of y. X and y should be both positive or greater than equal to 0. So it should be 0, 1, 2, 3, 4, and so on. An example for that is square root of 9 times square root of 5. You can write this as square root of 9 times square root of 5. And that's going to be, so square root of 9 is 3. So that's going to be 3 times square root 5. You saw this in a previous example when we had the 200. So remember this previous example, you had 200, and then we write it into as 100 times 2, and we separate them as square root of 100 times square root of 2, and that's 10 square root 2. For the quotient property of radicals, the square root of quotient may be written as the quotient of square roots of the dividend and divisor. Similarly, as multiplication, we can separate the x and y. In division, we can separate the numerator and denominator. So square root of x over y can be written as square root of x divided by square root of y. In this case, x should be always greater than equal to 0. but y should be strictly greater than 0. Y is in the denominator, and in the denominator you cannot have a 0 in the denominator, so it should be strictly greater than 0. An example of that is square root of 3 over 4 is square root of 3 divided by square root of 4. Square root of 4 is 2, and the square root of 3 written as is. Example number 2, product and quotient property of radicals. So we are going to use the product property here. We are going to divide the 27 into two numbers, multiplication of two numbers. One of them should be perfect square and the other could be any other number. So if I decide to break 27, I will break it as 9 times 3, because I know that I have a square root of 9 and I can break it into 9 times 3. Now I'm going to separate them as square root of 9 times square root of 3. Square root of 9 is 3, so you're going to write as 3, and the other square root of 3 remains as it is. So square root of 9 is 3 and square root of 3 remained as is. So our answer should be 3 square root 3 times square root 3. Letter B, when you're going to deal with the quotient or division property or quotient property, you first have to look if the 15 and 64, if you can reduce them, means they go on the same table. I can see that the 15 and 64 do not go on the same table. It means we cannot reduce them. So my only option is to separate them, the dividend on the top and the divisor on the bottom. The 15, number 15, we do not have a perfect square for 15, but we do have a perfect square for 64. And then the perfect square of 64 is 8. So the answer is square root 15 divided by 8. You try problem number 5. You're going to divide the 48 into two numbers. So the two numbers are 16 times 3 that I chose because 16 has a perfect square. So you can separate them as a square root of 16 times square root of 3. Square root of 16 is 4, so is 4. Negative sign remain as it is negative 4 times square root of 3. Question number 6 is you're going to separate the dividend, which is square root 23, divided by the divisor, square root of 9. Square root of 23 remain as it is, and square root of 9 is 3. 45, you can multiply 9 times 5, and you can separate them as square root of 9 times square root of 5. That is 3 times square root of 5, and that's going to be your answer. For number 8, you're going to separate the dividend and divisor. Bottom number you have 10 because square root of 100 is 10. On top you have square root of 9 times square root of 3. So that's going to be 3 square root 3 divided by 10. Next we are discussing example number 3, evaluating radical. When you have A, B, and C are given, and we are going to plug the values inside the radical symbol. So what you have here is negative 8 square, which is b square, minus 4 times 2 times 4, and that's going to give us 64 minus 32 and 64 minus 32 is square root of 32. Now we are going to break 32. So there are few ways we can break 32 as. So you can break it as 8 times 4. And that is going to be square root of 8 times square root of 4. Square root of 4 is possible, that is 2, and then square root of 8. This is not the final answer because there is a 1 square root hidden in 8. That is, you can further break down into 4 times 2 because 4 has a square root that is 2. And then you can have 2 times 2 square root 2, which is 4 square root 2. So there are few ways we can break 32 down, but this is not the preferable method to break the 32 down because we have to do a little more steps to get to the answer. We can break 32 as 16 times 2 because 16 is the biggest square root in 32. So square root of 16 times square root of 2, square root of 16 is 4, square root 2. If you notice that this answer 4 square root 2 and this answer are same, but we approach them differently. In this case we have to break them into few steps. In this case we just have to find the biggest square root, that is 16, and write the answer.